Next, this is the sigmoid pattern of the dissociation curve. This is the sigmoid pattern of the dissociation curve. So, oxygen hemoglobin dissociation curve is formed from alloy to tissue stage. In alloy stage, PCO2, partial pressure of O2. PCO2 means partial pressure of O2 is high, and PCO2, partial pressure of carbon dioxide, is low, and less H plus ions. At alloy stage, high PO2, low PCO2, and less H plus ions. Then form the oxyhemoglobin curve. So this is the oxyhemoglobin curve. So it is the partial pressure of O2. This is the partial pressure of O2, and it is oxyhemoglobin saturation period, hemoglobin saturation curve. Okay, this is a oxyhemoglobin saturation, and it is a PO2, partial pressure of O2. Then 10 ml of PO2, then hemoglobin saturation is 50%. Okay, so then form the oxyhemoglobin curve. At alloy stage, high PO2, then form the oxyhemoglobin curve. At tissue stage, low PO2, high PCO2, high H plus ions, then form the dissociation of oxyhemoglobin. Okay, alloy stage, high PO2, then form the oxyhemoglobin. Low PO2, then dissociation of oxygen and hemoglobin, separated into oxygen and hemoglobin. So this is the oxygen hemoglobin dissociation curve. Okay. And next one, transport of carbon dioxide, CO2. Transport of carbon dioxide, CO2 transport. Mainly CO2 transport to three types. First one, in dissolved state. In dissolved state. And second one, as carbamino compound. And third stage, as bicarbonates. So the transport of CO2, mainly three types. First, in dissolved state, and second as carbamino compound group, and third one as bicarbonates. Okay, CO2 transported by these three methods. So first one is the dissolved state. 7% of CO2 carried in dissolved state. How much? 7%. Okay, so dissolved state, 7% carried dissolved state through the plasma. CO2 plus H2O gives rise to H2CO3. CO2 plus water, dissolved state, water, then form the H2CO3. Okay, And next, second stage as carbamino compound. Second stage, carbamino compound. Okay, it is 20 to 25% of CO2 directly combined with amine group of hemoglobin, then form the carbaminohemoglobin. 20 to 25% of carbon dioxide combined with amine group of hemoglobin. So then form carbaminohemoglobin. Okay, so hemoglobin, amine group combined with amine group plus CO2, then form carbaminohemoglobin. Okay, this is carbaminohemoglobin plus CO2 mixed with carbaminohemoglobin compound is formed. So the CO2 transport as carbamino compound by 20 to 25%. Okay, and dissolved state 7%, 20 to 25% carbamino compound. And next one, third stage as bicarbonates. It is 70% of CO2. 70, how much? 70% of CO2 transported as bicarbonates. Okay, so RBC contains a very high concentration of the enzymes carbonic anhydrase. RBC contains a very high concentration of enzyme carbonic anhydrase. This enzyme facilitates the following reactions. This enzyme mainly divides to CO2 plus H2O gives rise to H2CO3 by the enzyme of carbonic anhydrase. And H2CO3 then deviated into HCO3 minus and H plus ions. So H2CO3, H plus ions, one H plus ion separated, then form the bicarbonate. So HCO3 minus is bicarbonate. So by the enzyme is carbonic anhydrase enzyme, carbonic anhydrase. First of all, water and CO2, then form the H2CO3, and H2CO3 then using the carbonic anhydrase enzyme then form the HCO3 bicarbonate, HCO3 minus bicarbonate, and separated the H plus ions. So this is 70% of CO2 transfer. Next, disorders of respiratory system. Disorders of respiratory system.